In this video, we're going to show one of the features of SLIKWORKS, which is its ability to upload an architecture and create a form sheet from it. In traditional FMEA tools, one of the challenges that people face is to build the boundary diagram on which the FMEA should be performed. In a lot of cases, people are rebuilding boundary diagrams, and based on the boundary diagrams that they build, they have to create failure modes and causes for each of the elements of the boundary diagram. In SLIKWORKS, what we try to do is we don't want the user to recreate something that is existing. We want the user to just upload an existing architecture diagram. The image recognition algorithm within SLIKWORKS will extract all the elements and it will spit out all the elements of the architecture. And then it automatically predicts failure modes and causes for each of those elements. We're going to do that with a simple example. We're going to start a new project. Let's call it electric powertrain. We're going to take a very simple architecture of an electric powertrain. We're going to create an FMEA for this. We're going to use the default template. The first thing we need to do is upload an architecture diagram. What we have here is we created an architecture diagram, which is a system architecture. We created the system architecture in Visio, and then we converted this into a PNG file. We downloaded this, and now we're going to upload it. I'm going to quickly open the architecture diagram to show what it looks like. So this is what it looks like. In traditional tools, what we would do is we would say this is the boundary diagram. Now, for each of these elements, we would sit and write down failure modes. For electric motor, we would sit and write down some failure modes. For front electronic motor control unit, again, we would write down manually in the tool, FMEA tool, and we write down all the failure modes. We're trying to avoid all of that. We're trying to automate all of this in SLIKWORKS. So what happens is we just upload this architecture diagram. The image recognition algorithm in SLIKWORKS is going to identify each of these elements. It's going to identify the IO for each of these elements. And then for each of these elements, it's going to start creating failure modes and it's going to populate causes. So let's take a look at this example. So I uploaded the architecture diagram and I say use AI to extract components. The AI part here is the image recognition algorithm. So it's identified all these elements, and we can go into each of these elements to see what is the metadata that identifies. So let's take the first element on the left. It's an accelerator pedal sensor 1. It's just a sensor that is sending out one signal, which is the accelerator pedal sensor 1. So that is denoted by this element. And if we click on edit component, we see that it is the component name is accelerator pedal sensor 1. It's identified the type of component as a scalar sensor as opposed to a vector sensor. A scalar sensor is one-dimensional, a vector sensor will be multidimensional. For example, if you have inertial sensors, or if you have magnetic field sensors, they'll be vector sensors. There is a database of component types within SLIKWORKS, which is constantly being updated. Why this is important is SLIKWORKS identifies accelerator pedal sensor 1 as a scalar sensor. In the database internally within SLIKWORKS, scalar sensors have a set of failure modes. When it's identified as a scalar sensor, when the form sheet is created, those failure modes from the database get populated. In addition, for each of those failure modes, there are some causes that uh, are stored in the database. They automatically get populated. Number two, we also see that the inputs and outputs are determined. In this case, there's no input. It's really the starting of the sensing chain. It's got one output. Why this input output is important is when we create a form in the form sheet, when we create the failure modes for accelerator pedal sensing, one of the causes of failure is the accelerator pedal sensor 1 input, which is a failure of this pedal. Sensor 1 could be too high, too low, missing, whatever it is. That is one of the causes. Because under accelerator pedal sensing 1, we've identified accelerator pedal 1 as an input, a failure of accelerator pedal 1 will show up as a cause in the form sheet. And if you quickly go to accelerator pedal sensing element, click on edit component, we see that it's got two inputs. One is pedal sensor 1, pedal sensor 2. And this input, these two inputs will show up in the form sheet as potential causes for any failure mode of accelerator pedal sensor 1 and 2. So similarly, it has identified all these elements of accelerator pedal sensor 2. If you take a look at brake control unit, it will have identified this as a control unit. Brake control unit, it's identified it as a processing unit. There's a set of failure modes for a processing unit. Similarly, if you look at front motor control unit, identified it as a processing unit. If we go into the powertrain control unit, there are all these elements which are, you could say, functionalities. The SLIKWORKS tool identifies each of them as functionalities. So for example, accelerator pedal sensing, it's identified it as a function. What this means is for all the components that it has identified as function, you can do a has-up. So you can combine the function with some keywords, and this will be used by SLIKWORKS to create failure modes. So for example, if you create, if I would say no not, which means does not perform accelerator pedal sensing, or I could say more, or I could say less. I'm going to press save changes. So this is the architecture. This is the architecture upload feature. Now I'm going to show you how this reflects in the form sheet. I have already added some effects. I've added some safety measures, which are coming from the HARA and from the technical safety concept. And just to focus on the form sheet, I'm going to open the form sheet, and I'm going to open this is generated form sheet. And if we look at one of the components, pedal sensor, you can see that it's already identified some failure modes. Sensor signal offset, sensor signal out of range, stuck in range, sensor signal oscillations. It's possible for the user to add more failures. But the fact that during the architecture phase, SLIKWORKS identified this as a scalar sensor, these failure modes are coming up. And then if you open one of them, it will even show what is the cause of failure. So it would say in this case, cause of failure, component degradation, or it could be incorrect calibration, unstable power supply. These are three causes. So all of this is coming from an internal database. Now we can take an example of a function wherein this accelerator pedal sensing was identified as a function where we did a hazard, and you can see that we've selected three failure modes. The failure mode, it just adds the keyword over here, which is not ideal, so the user can change this to does not perform sensing, and then here the user can modify this to and over here we could change this to no accelerator. Finally, we have this communication failure. What this communication failure is, it looks at all the failures of the inputs. So here we have failure of accelerator pedal 1 is one of the failures. So if you look at the architecture, it looks at failure of accelerator pedal 1 and it identifies this as one of the causes of failure. So this, in a nutshell, is what is happening with the architecture. The key takeaway here is the user does not have to manually sit and work on the architecture and identify elements and failure modes. The tool will do the work for the user. The user is only managing the tool now. We're hoping that this will improve the quality of life of safety engineers, especially when they're performing an FMEA.